Well, we are going to start science. And actually, I think right before spring break, which was like a month ago, um, we had started Unit 5. We're talking about clouds, remember? And we did a couple different little handouts and so forth. I wanted to make certain that everybody had a chance to bring their science grade up because we didn't have that many grades in there. But we were learning about clouds and how fun they are to watch and to look at, and that they got crazy names, right? But we want to go over what we've written or highlighted and then answer some comprehension checks. So you will need a sheet of paper. Da-da-da. And you're gonna put name, subject, date. Yeah, name, subject, date. Yeah, all right. And that pen does not work. In the trash with you. In the trash. All right, let's see if this one works. Better. Name, subject, you're gonna write science 5.1 and 5.2. What? Okay. And then today's date, 4/14/20. And we'll skip a line and we'll do number 1. So it'll look like this. And we'll go through and we'll answer them, okay? And we'll only have to write the answer. Just the answer, not in a complete sentence. You don't have to write the question. You're just going to write the answer, okay? So I'm looking at page 102, and it's talking about matter, water, air, and weather. And boy, have we had some weather. Man, Chattanooga got hit as hard as Nashville and, oh, goodness, where is it? Lebanon, Hermitage area. I mean, it got hit bad. Louisiana, but it was the northern part of Louisiana, Monroe, so that you had like Louisiana, Mississippi, Alabama, and then Tennessee, goodness knows. Anyway, we know by looking at what we highlighted, parents, if you are watching with us, we go through and we read, we highlight specific areas that Miss Taylor, that I tell, that seem to deem importance so that we can easily go back into our text and find if we need some information. So on page 102, it says 3/4 of the earth is covered by oceans, lakes, and rivers. 3/4. It's a lot of water. Okay. Water is found not only in oceans, lakes, and rivers, but also in the soil. You can highlight that. That's on top of page 103. Then we went on and found that large amounts of water are also found not only in the soil, but in the air. Right. Every day, each man, woman, and child throws out from the skin water into the air. Yuck. What if you're not clean? What if you stink? So it says that people and animals also release water into the air. Every day, each man, woman, and child throws out from their skin as perspiration, sweat, and from the lungs as moisture in the air that they breathe out, an average of nearly 1 quart of water every day. Wow, who knew? So this is on page 103, first column, third paragraph. Then we go on to clouds, which is what we were studying right before we left. Okay, we highlighted quite a bit of the cloud part, and I'm just going to reread the highlighted part, and you will follow along. 103, second column, clouds. Clouds are made of mostly water and air. Although most clouds look fluffy and light, a single cloud may contain from 100 to 1,000 tons of water. How high are clouds? Each kind of cloud has its own range of height. The height of the cloud also depends upon the condition of the atmosphere, the area or the layer of air surrounding the earth. The more humid the air is, the lower the cloud will be. When a cloud is so low that it is at ground level, we call that fog. Clouds which are high up in the sky are made of tiny ice crystals. Clouds which are low are made up of very tiny droplets of water. Each of these droplets is so small that it would take about 1 million of them to make a raindrop. Clouds are always changing shape because whenever warm air touches a cloud, some of the cloud evaporates. Clouds are divided into 3 main groups. Okay, depending upon their shape, you will learn to recognize these shapes, and later you will learn how they are combined to form different kinds of clouds. That's where we were going through the different kinds of clouds. And if we remember, when you flip the page to 104, see where we are right there? It'll give us the different types of clouds, and we'll see from fog all the way up, okay, by the height, the condition of the air. I could not make it as a weather meteorologist. No, there's just no way. Okay, good thing I'm teaching. All right, here we go. There's a cirrus cloud, and the word cirrus means curly. So cirrus clouds, they're thin and feathery because they are very high up in the sky, and they're made entirely of ice crystals. Cirrus clouds look hazy and delicate, and usually they appear in dry weather, but they often mean that a storm is on its way. So if we look, very top, this is the cirrus clouds. All right, cumulus. They are large puffy clouds that you often see on a hot summer afternoon. They have flat bottoms and a high domed top, like heads of cauliflower. I don't think about cauliflower when I look at clouds. Usually, cumulus clouds are bright white and appear during fair weather, but sometimes they become thick, heavy, and dark. When they're called thunderheads because of the heavy rain, thunder, and lightning that they will bring. All right, so if you see number 2, it's in fact, if I'm looking outside right now, I want us to do that. I think we have a combination of these cumulus clouds, right? So that's one of our things. You're going to go outside and look at the clouds. All right, and then stratus. Stratus clouds are thick layers of clouds that look like a blanket. They are flat and often gray, and they frequently bring drizzling rain or fine snow. They are fairly low clouds. So it's almost kind of like it's a blanket that's covering, kind of on a hazy day too, right? So this is stratus. All right, and then fog. We know that fog is the stratus cloud, but it's very close to the Earth's surface, and we know that. Again, so we have cirrus, cumulus, stratus, and fog. Got them? All right. Now, we're going to complete the comprehension check that's just right down there. I don't remember that we did this before we left or not. So we'll just go ahead and do it. In fact, I have it written out for you. I will also take a picture of this and post it on Facebook because I want to read the question and I want to answer it, but I don't want, you can pause the video. In fact, if you want to do that, here are the answers. Can you see all of them? If you pause, there you go. You'll be able to look at them. In the meantime, I'm going to read aloud and then you'll be able to see this. How much of the Earth's surface is covered in water? You are correct, 3/4. So what are clouds made of? They're made of water and air. So they're going to give us all these different characteristics and we have to name which kind of cloud it is. All right? So if I have a large and puffy cloud, cumulus. This is light and feathery, cirrus, way at the top. It looks like a blanket, stratus. D, sometimes it forms thunderheads, cumulus. All right, E is called fog when it is very low to the earth. Okay, that again is a stratus cloud. Okay, we're on E. It's a stratus cloud, but we refer to it as fog, right? Okay. This is made of air and ice crystals. Cirrus, way at the top, because it's really cold up there. Okay, G is often a sign of an approaching storm. Okay, so it's a precursor to a storm coming, and that's cirrus clouds. H usually brings light rain or snow. Stratus, it's the blanket, remember? And then the last one, I, usually appears during fair weather. Cumulus. Yes. All right. So that was pretty easy. We could have whizzed through that. But I want us to read 5.2, Water for Life. And as I am reading, I'm going to tell you what you need to highlight, and we'll go from there, okay? Necessary for life processes. Because all living things contain water, nothing could live without it. Well, we know that. Nothing can live without water. Highlight that. The kangaroo rat, which lives in the desert, is about 65% water. But the jellyfish, which lives in the sea, is about 95% water. All living things need to take in water so that their bodies can perform the process that keep them alive. So I need you to highlight that. All living things need to take in water. Okay? Do you know that you are about 65% of water? How about that? Your body needs to take in about 2.5 quarts of water each day. You get this from the water and other beverages that you drink and from food that you eat. The driest food, baked pumpkin seeds. Why that's the driest food, I don't know. There's 5% of water in them. The food that contains the most water are very appropriately named. Watermelon. That's right, watermelon has 97% water. I love watermelon, don't you? Especially if it's cold. I like it cold. I don't like it warm. If you do not take in enough water each day, your body cannot function as it should. Your blood uses water to help it flow throughout your body, carrying nutrients and waste products. As the body loses water throughout the day, the blood tends to become thicker and more difficult to pump. The heart must work harder to pump blood that does not have enough water. Oh, it makes me thirsty. You cannot live for over a month without eating food, but if you went without water, you would die in about a week. Ooh, it's kind of startling. Different plants and animals need different amounts of water in order to live. Some kinds of animals, such as jellyfish, must spend their entire lives in water. Others can go for long periods of time without drinking water. The camel can live for months without taking a drink. God designed its body so that the camel can get the water it needs when it uses the fat that's stored in its body. Some animals never drink, but they still need water. The kangaroo rat gets all the water it needs from the dry seeds that it eats. Scientists have found that the kangaroo rat gets 2 ounces of water every 5 weeks from its food. Okay. Although they require a different amount of water, all animals would eventually die if they were forced to do without the water that they need. When you consider all of the plants, animals, people that there are in this world, is it any wonder that God created so much water? Good answer. Good answer. We highlighted water. You can't live without it. All living things need water. That your body is 65% water. Watermelon is 97%. And they told us that you would die in about a week if you did not have water. And let's look at water is matter. We're on page 105, second column. All right. If we were in my classroom, I'd be calling on one of y'all to read because I think I need a drink of water. Okay. Although water is a very common substance, it is an unusual substance. In order to understand just how unique water is, we must first understand what all the things around us are made of. All the things that you can see are matter. So highlight that. Matter is anything that takes up space and has weight. Your desk, your books are matter. Since your body has weight and takes up space, it's matter. There are some things which are real but are not matter. God is not matter. The Bible tells us he's a spirit. Love, wisdom, truth are also real things, but they're not matter. None of these real things take up space or have weight. Your brain, most of you, your brain is matter, but your mind is not. Is water matter? Well, how do you know? Tell why each of the things is or is not a matter. A thought? No. A brick? Yes. Takes up space, has weight. An acorn? Yes. Peace? Not matter. Hope? Not matter. All right. You get it. You understand what we're doing here? Okay, so we're on page 106. Matter is made up of molecules. All matter is made up of tiny particles called molecules. Highlight that first sentence. A molecule is the smallest piece of substance that is still has all the qualities of that substance. The smallest particle of water is a water molecule. So highlight that. Water molecules are very tiny. If you could line up 60 million molecules of water side by side, they would reach across the face of a penny. Do you think you could see a molecule of water? No, not with your naked eye. Nope, cannot. All right. So molecules are made of atoms. If a molecule of water is broken down into smaller particles, the particles are no longer water. These particles make up molecules, which are called atoms. All right, so you have an atom, then you have a molecule, and then you have water, or a substance, okay? Atoms are so small that they are 500 billion trillion atoms in every teaspoon of water. What? A water molecule is made of hydrogen and oxygen, so you need to highlight that. Every water molecule is made of 2 atoms of hydrogen and 1 atom of oxygen. Hydrogen and oxygen are gases found in the air. This is how God's so cool. God designed it that way. That when 2 atoms of hydrogen and 1 atom of oxygen join together, they make a molecule of water. Highlight that. In fact, it's in bold, I think, on the top of your page. During the process of photosynthesis, a leaf uses the energy of sunlight to split water molecules into atoms of hydrogen and atoms of oxygen. The leaf uses the hydrogen to make simple sugars by combining it with the carbon dioxide from the air. Remember, we breathe in oxygen, but we breathe out carbon monoxide. All right. Sugar is made of carbon, oxygen, and hydrogen. The plant releases extra oxygen into the air so we can breathe, where it can be breathed by people and animals. This is all part of God's wonderful balance of nature. And there is more. Did you know that the cells of your body produce water every day? Your cells and cells of animals have been designed to use the oxygen taken in by breathing to help you release energy from food. In this process, hydrogen atoms from food combine with oxygen from breathing to form water. Carbon and oxygen from food are released as carbon dioxide. Both carbon dioxide and water molecules are released into the air when people and animals breathe out. Then, what becomes of them? So, what I want you to do is I want you to look at this cool diagram at the very bottom, and I'm wanting you to try to draw this on your own. Okay? I want you to try to draw this on your own. It's really cool. So bottom line is you need to have hydrogen and oxygen. So we're going to try to draw those together. So if you'll see, it says 2 hydrogen molecules plus 1 oxygen molecule will give us 2 water molecules. Because if you'll see, for every 1 oxygen, I have to have 2 hydrogen. So it would look something like this. Let's see if I can draw it really cool. So I have oxygen, and then I have and this is water. What? So what you're doing is you have 2 hydrogen and 1 oxygen, and they're going to equal a water molecule. So I want you to kind of draw a couple of them. It's kind of fun, and you can color them however you want to, okay? But when they are together or attached, that's what happens. We'll do some more basic atoms and different molecules. It's fun. That's one of the classes that you'll take when, I don't know if you start it in middle school, you probably do, probably like 6th or 7th grade you'll start that, but when you get into chemistry, fun stuff. All right, so 5.2, page 106. What is the percentage of water in your body? Yes, 65%. How much water do you need to drink every day? 2.5 quarts. What happens to your blood if you do not replace it? Your blood becomes what? Thicker, okay? And then it makes it what? How does this affect your heart? It makes it harder to pump the blood because it's thicker. Number 4, what is matter? Anything that takes up space and has weight. Are you matter? Yes, and you do matter too, but you are matter. What is a molecule? The smallest piece of a substance that still has the qualities of that substance. That's a molecule. But what are the particles that make up a molecule called? So you have a water molecule, but it has 2 different components, hydrogen and oxygen. So what are those little particles called? They're called atoms. Number 7, what happens to molecules of water during photosynthesis? Bottom line, you're just going to say they split into hydrogen atoms and oxygen atoms. You're just going to say they split, okay? And then number 8, what happens to atoms of hydrogen and oxygen when your body uses food? They combine together and they make water. Pretty cool. Now I want you to go outside and figure out what kind of clouds there are, and I want you to type underneath this in Facebook what kind of clouds you see. All right? Cloud hunting, here we go.